Good day, this is the Professor, Professor CBMD PhD. Today's Thursday, July 28, 2022. It's 1:12 and 56 seconds, p.m. Eastern Standard Time. And today's research, machine vision. So let's hop to it here. Improving image sensors for machine vision. On-chip spectrometer. Silicon nanowires. Determine light spectrum. Angle. Date July 26, 2022. Source, American Institute of Physics. Researchers highlight the latest nanostructure components integrated on image sensor chips that are most likely to make the biggest impact in multi-modal imaging and detailed a promising approach to detect multiple band spectra by fabricating an on-chip spectrometer. The developments could enable autonomous vehicles to see around corners instead of just a straight line. Biomedical imaging to detect abnormalities at different tissue depths, and telescopes to see through interstellar dust. Image sensors will gradually undergo a transition to become the ideal artificial eyes of machines. An evolution leveraging the remarkable achievement of existing imaging sensors is likely to generate more immediate impacts. Imaging sensors, which converts light into electrical signals, are composed of millions of pixels on a single chip. The challenge is how to combine and miniaturize multifunctional components as parts of the sensor. In their own work, the researchers detail a promising approach to detect multiple band spectra by fabricating an on-chip spectrometer. They deposited photonic crystal filters made up of silicon directly on top of the pixels to create complex interactions between incident light and the sensor. The pixels beneath the films record the distribution of light energy from which light spectra information can be inferred. The device, less than 1/100th of a square inch in size, is programmable to meet various dynamic ranges, resolution levels, and almost any spectral regime from visible to infrared. The researchers built a component that detects angular information to measure depth and construct 3D shapes and subcellular scales. And their work was inspired by directional hearing sensors found in animals, like geckos, whose heads are too small to determine where sound is coming from, in the same way humans and animals can. Instead, they use coupled eardrums to measure the direction of sound within a size that is orders of magnitude smaller than the corresponding acoustic wavelength. And similarly, pairs of silicon nanowires were constructed as resonators to support optical resonance. The optical energy stored in two resonators is sensitive to the incident angle. The wire closest to the light sends the strongest current. By comparing the strongest and weakest currents from both wires, the angle of the incoming light waves can be determined. Millions of these nanowires can be placed on a 1 square millimeter chip. The research can support advances in lensless cameras, augmented reality, and robotic vision. Good day, this is the Professor, Professor of Astrophysics, Optics and Science, and Electronic Engineering. Well, this video was created for educational purposes only. Hope you enjoyed listening. Until next time, have an awesome day.